Alright, in this video we will find the value, the exact value, no decimals, of these trigonometric functions. What I'm about to show you only works for special angles, special reference angles. So the special angles, remember your 45, 45, 90 triangle? So 45 degrees is a special angle. Remember your 30, 60, 90 triangle? So 45 degrees, 30 degrees, 60 degrees. These are special angles with special values. Now 45 degrees is the same thing as pi over 4. Okay, so pi over 4 in radians is a special angle. I'm seeing that showing up right here. See this 3 pi over 4? That's your pi over 4 that's happening. Alright, that's why this is a special angle. 30 degrees is the same thing as pi over 6 radians. So see how that's showing up right here? That's your pi over 6. Alright, that's the reference angle. So that's going to be the reason why we can do this. Okay, so if these weren't special angles, we would have to do something different than what I'm about to show you. But that's for another video. So for right now, what you need to understand is the function of any angle is going to be the same thing as the function of the reference angle, except for one thing. Maybe it's negative, but that's the only difference. So the tangent of 7 pi over 6, as soon as I realize that the reference angle is pi over 6, then I know the tangent of this is going to be the same thing as tangent of pi over 6. Except for I need to figure out whether it's going to be negative or not. And here's how I can figure that out. I do a little sketch and pay attention to the quadrant. So I'm going to do my little sketch right here, my friends. And I'm going to draw the reference angles. So pi over 6 is 1/6 of pi. The top half of my circle is pi. So I'm going to divide this up into 6 pieces. And then each one of those will be pi over 6. Wow, that's a crooked line. Hey guys, drawing with an electronic pen like this is tricky, so don't judge me. So notice how I have 6 pieces here in the top. So when I go to look for 7 pi over 6, it goes like this. 1, 2, 3, 4, 5, 6, 7. 7 pi over 6s. I'm going to land right here in the third quadrant. So the question is tangent positive or negative here? Well, I know that tangent is positive in this quadrant. Alright, now I will briefly remind you of why that is. I think I'll open a new document to show you, so I have space. I need scratch paper basically. So look guys, remember, sine and cosine are x and y. Okay, on the unit circle, every point x comma y, the x value is cosine and the y value is sine. So let's talk about where the x and y are positive and where they're negative. Now in this quadrant, it's to the right. All these points are to the right and up. So the x value is positive and the y value is positive. Cosine and sine are both positive. In this quadrant, the x values are negative because they're to the left. The y values are positive because they're up. In this quadrant, all of these points are to the left and down. So that's negative and negative again. In this quadrant, these points are to the right and down. So that's positive and negative. So that's what's going on with cosine and sine. But remember that tangent is sine over cosine. That's something that we need to memorize. In other words, as far as the unit circle goes, the tangent is going to be the y value divided by the x value of the coordinates. Let me change colors as we talk about the tangent. So this is the y value, this is the x value. So if I want to do the tangent, it's going to wind up being y divided by x, a positive divided by a positive. Well, guess what? A positive divided by a positive is a positive. So tangent is positive in this quadrant. In this quadrant, I will wind up doing a positive divided by a negative. A positive divided by a negative is a negative. In this quadrant, when I go to do y divided by x, that's going to be a negative divided by a negative. A negative divided by a negative is positive. So tangent is positive in this quadrant. And in the fourth quadrant, I will wind up doing a negative divided by a positive. That is a negative. So tangent is positive in the first and third quadrants. Tangent is negative in the second and fourth quadrants. So going back to our actual problem, that's why I know that tangent is positive here in the third quadrant. Okay, so I don't need a negative sign. So all I really need to know is what is the tangent of pi over 6. Now is a good time let's use our scratch paper to make the chart. Alright, I hope you know that there are 3 key facts that if you memorize the 3 facts, you should be able to find all the other facts that you need based on that. So I'm going to draw a chart, and you should be able to draw this same chart in just over a minute. Okay, so the chart goes like this. 45 degrees is the same thing as pi over 4. So let's get that out there. And let's see, 30 degrees is the same thing as pi over 6. And 60 degrees is the same thing as pi over 3. Now, for each of these, we're going to have the sine, the cosine, and the tangent. So let me start with the 3 things that you have to just memorize. Okay, you have to memorize that the sine of pi over 4 is 1 over radical 2. Just memorize that. Also, you have to memorize that the sine of pi over 6 is 1/2. And you must memorize that the cosine of pi over 6 is radical 3 over 2. Memorize these 3 facts. Everything else will just fill itself in as if by magic. Now, here's how you fill in the rest of this chart. First of all, now I need cosine of pi over 4. But just in the back of your head, understand that the cosine will be the same as the sine of pi over 4. So you don't have to memorize it because you know that they're always the same. So 1 over radical 2 again. Let's come over to 60 degrees, or pi over 3. I need the sine of pi over 3, and I need the cosine of pi over 3. You don't have to memorize these as long as you understand that these are just the reverse of what you had for pi over 6. So the radical 3 over 2 is going to be for sine this time, and the 1/2 this time will be for the cosine. So you don't have to memorize it, just remember that you have to switch them. Now let's talk about tangent. And let's see, I'm going to switch to gray for some reason. When we do the tangent of each of these, so I'm going to do the tangent of pi over 4. Remember from up here, tangent is sine over cosine. Now look at our chart. We have it set up already in that order. Sine over cosine, sine over cosine, sine over cosine. So if I want to do the tangent of pi over 4, I just have to do this divided by that. Well, for this first one, anything divided by itself is 1. So the tangent of pi over 4 is 1. what about the tangent of pi over 6? Well, I'm just going to do 1/2 divided by radical 3 over 2. Now look, these denominators, see how they're both 2? They just cancel each other out. Don't worry about that. Look at the numerators. So it'll be 1 over radical 3. Okay, just look at the numerators. And similarly for the pi over 3. So I'm going to do tangent of pi over 3. Sine over cosine. Again, the denominators are going to cancel each other out. So it'll just be radical 3 over 1, which is just radical 3. So from these 3 facts shown here in pink, I was able to get everything else that I could ever want. Let me just throw in one other bit of knowledge to you. 1 over radical 2, if you rationalize the denominator, that is the same thing as radical 2 over 2. Alright, those are interchangeable. And similarly, 1 over radical 3 is the same thing as radical 3 over 3. So these will be used interchangeably. Keep that in the back of your mind. Anyway, what were they asking us for again? The tangent of pi over 6. Let us consult our chart. Tangent of pi over 6 is 1 over radical 3, or radical 3 over 3. Okay, so that's what it is. So we could just put 1 over radical 3 or radical 3 over 3. I will accept either one of these. Okay, let's go again. One more time. Now I see that we are being asked to find the secant of 3 pi over 4. I know that secant is the reciprocal of cosine, so my strategy will be to first find the cosine and then just do the reciprocal. So let's reframe the question and ask ourselves, what is the cosine of 3 pi over 4? Well, forget the 3 for a second. What's the cosine of pi over 4? In other words, the reference angle is pi over 4. So the cosine of 3 pi over 4 will be the same thing as the cosine of pi over 4, except for it might need a negative sign on it. So what is the cosine of pi over 4? Well, remember, that's one of the values that we have memorized. So the cosine of pi over 4 is 1 over radical 2. And that's the form I'm going to use for this problem. So the cosine of pi over 4 is 1 over radical 2. That means the cosine of 3 pi over 4 will also be 1 over radical 2, except maybe it needs a negative sign in front of it. Now, to figure out whether or not we need the negative sign, it helps to look at a diagram of pi over 4s. Okay, so here I'm dividing the top half into 4 pieces because that's pi, and now I've got pi over 4. 3 pi over 4 is going to be right here because 1, 2, 3 pi over 4. So notice that this is in the second quadrant. So is cosine going to be positive or negative over here? So just remember that cosine is an x value on the unit circle. So of course this is going to be negative because x values are negative to the left of the y-axis. Alright, so cosine of 3 pi over 4 is going to be negative 1 over radical 2. But don't forget, we really want the secant. So if we want the secant, we are going to need to do the reciprocal of this, which will be really easy because we chose the form 1 over radical 2. So the reciprocal of that would be negative radical 2 over 1, which of course is simply negative radical 2. So that's the final answer for number 6, part B.